Bismillahirrahmanirrahim. Assalamu alaikum everyone. Myself Dr. Mamoona Azhar. By profession I am a physiotherapist and today I am going to deliver a lecture on the subject of medical physics. And in today's lecture we are going to study about stimulation of innervated muscles. In the stimulation of innervated muscles you got to know about its introduction. So in today's lecture we are going to get to know about the rate of change of the current, duration of the stimulus and poles used for the stimulation. So rate of change of current. A current which changes in intensity suddenly would like to be more effective in stimulation of innervated muscle. How and why? For example, the current which is changes in intensity suddenly, the intensity is changing very quickly. So in that kind of situation, the accommodation for the muscles is difficult. So when there is less accommodation, obviously the current is being more effective and can be used for the longer time. For example, we are using the rectangular current. So this type of current, it is increasing in intensity, it rises in intensity suddenly, maintain it and fall suddenly. So this type of current has very less chances for accommodation. So it is very effective. But when we move towards the triangular one, the trapezoidal one and the sawtooth, when we use these type of current, they increases in intensity slowly, gradually and decreases in intensity gradually. So there are increases chances of accommodation. So that kind of current would not be that much effective in producing innervation or stimulation of innervated muscle. And the slower the rate of change of current, greater is the intensity needed. Slower the rate of change of current, greater is the intensity needed and to be effective, and a current which rises and falls very slowly does not produce muscle contraction. So when this type of current which is increasing and decreasing very slowly, it is not producing the contraction very effectively. Duration of the stimulus. To demonstrate the effect of stimuli, different durations of the interrupted direct current, as we know that there are multiple durations which are being mentioned, starting from the 0.01, 0.03, 0.01, 0.03, 0.1, 0.3, 1, 3, 10, 30, up to 100. So up to 100 the stimuli, as you can see that the duration of the current would be in millisecond and it is having the multiple durations. And which duration is effective and how we can produce contraction from it. So we are taking the 100 millisecond of the current and we are going to see that at what duration and what intensity minimal contraction is being obtained from this type of current. So for understanding this concept, there is a graph which is being mentioned in your book and which can help you understand the concept very clearly. From that graph you would come to know about two different new things. For example, this is the y-axis and this is the x-axis. X-axis is the millisecond, means duration side, and y-axis is the milliampere, so it is intensity side. This is strength duration curve. In this curve you would get to know that at what duration of current and at what intensity of the current you would have the minimal contraction. So according to that, 0.01, 0.03, 0.1, 0.3, 1, 3, 10, 30, 100. So it is up to 100. And at this point, this is 6, it is 12, it is 20, it is 50. So we are going to draw a graph. The intensity of the current and the impulse shortened and intensity of current needed to produce a contraction again observed. So here we are going to observe the contraction and at what level a nerve impulse is initiated. So this strength duration curve where the current against the duration of the stimulus or the effective voltage may be recorded instead of intensity. Such a graph is termed as strength duration curve. So at this point, we are just going to see that different points are being mentioned. 10, 3, 1 is a bit higher, and 0.03 is above 12. Okay, and 0.01 is above 20, and 0.03 is above. So here are the different points which you can see at the surface, that the duration of the current and the intensity in the combination. So this is the minimal duration and this is the minimum intensity required to produce the contraction at different points. So we are going to join this. Here you can see, so this side was the duration and this side was the intensity. In this strength duration curve, I just mentioned that we will get to know about two new things. What are those? That is Rho base and the other one is chronexy. Rho base, the spelling is R-H-E-O Rho, B-A-S-E base, and chronexy, C-H-R-O-N-A-X-I-E, chronexy. What is meant by Rho base? What is the definition of the Rho base and what is meant by chronexy? Rho base is the minimum intensity of the current. Here you can see, this is the minimum intensity. The minimum intensity of the current that will produce a response if stimulus is of infinite duration. So the minimum intensity of the current that will produce response if this duration is infinite. So at this point we are just going to remember two things: the minimum intensity of the current and the minimum intensity of the current. You can see at the 130, 10, 33. Minimum intensity of the current if this duration is infinite. We are going to make this duration infinite, and the minimum intensity of the current produced at the point would be Rho base. Now moving toward chronexy. What is chronexy? The chronexy is the minimum duration of the impulse that will produce a response with the current double of the Rho base. So for example, this was the intensity of the current which was produced by the Rho base, and it was 6. And in the chronexy, if we double the intensity of the current is doubled, and it is doubled at the point of 12. So it is double at the point of 12. The intensity of the current is double at the point of 12. And what will happen at this point? The chronexy is the minimum duration of impulse that will produce a response with the current double of the Rho base. So the chronexy is about the duration. At what duration you would have the intensity of the current that would be double of the Rho base. So the basic intensity was 6 and the double of it will be 12. And at what duration we are going to feel that? So we are just going to identify that point. So this is actual point for this. Here you can see that this point, it is a bit between 0.3 and 1. So this is the point that would be known as chronexy. This is all about chronexy and Rho base and strength duration curve. Now moving towards poles used for the stimulation. A nerve can be produced and initiated by the rise and fall in the intensity of the current. When the current is rising and it is falling, it is producing the intensity. That intensity of the current would be effective in stimulation, in producing the stimulation in the innervated muscles. But rising in the current would be more effective than falling of the current. So, and in the rising of the current, it is commonly used for the nerve stimulation. Cathode would be more effective than the anode, because when the current rises, cathode would be more effective in producing the stimulation rather than the anode. So this was all about today's lecture. If you guys have any query or any question regarding this topic, you can ask me directly, you can comment, and you can WhatsApp me anytime. Thank you so much.